The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. Welcome to the second part of our NXP and ThinkStream webinar series. Part one, if you missed it, we talked about building intelligent, low-power connected things at a low cost. And today we're going to follow up with our final part of the series with designing and deploying intelligent, low-power and low-cost wireless networks. If you haven't seen part one, we will send out a recording link and the presentation material as well afterwards, in addition to the part two recording and presentation material. Do keep in mind that you can submit questions into the question box throughout the webinar, and we will have time at the end to answer all your questions. But without further ado, I will hand it off to Gordon.
Thanks, Ethan. And hi everyone. My name is Gordon Padkin. I'm working the regional marketing for NXP, and we are here with Bruce Jackson and Neil Hamilton. So from ThinkStream. So really, just to recap what Ethan said, we had ran how to build intelligent, low-cost, low-power networks last week on the 10th of May, and today on part two, we really want to focus on the cloud piece of the software and how to provision and manage these sensor networks. So in a minute, I'm going to hand over to Neil and Bruce, who are going to introduce the ThinkStream software platform and how they can manage and provision these sensor networks. I just want to very quickly recap a little bit from last week while everyone is joining and getting settled in. As a reminder, NXP, of course, is focused on delivering secure connections for a smarter world, and we're focused on delivering edge nodes, gateways, and cloud connectivity with NXP's product portfolios, including microcontrollers, microprocessors, NFC, RFID sensors, analog, and connectivity. And this solution that we present today is part of our strategy to provide our customers and developers the ability to deploy smart sensor nodes and be able to connect them through to the cloud securely and cost effectively. So the solution that we touched on last week focused on the edge part of the connectivity story. What we understand from the trends in the industry is that there is a huge amount of value in being able to connect lots of different edge node sensors that gives us access to more data that we can process in the cloud more effectively. And NXP, of course, provides ultra low power, low cost microcontrollers that can sit on the edge to perform these sensing and control functions. And last week we spoke heavily about the value proposition of the bundled software between NXP and ThinkStream that runs on top of these microcontrollers that then brings the connectivity to the edge. And then, of course, today we are going to talk a little bit more about how you can manage and provision these sensors using the cloud software platforms. So just to kind of emphasize the hardware part of it, of course, the solution that we bring built on top of NXP microcontrollers is the ThinkStream connectivity platform. The great thing about the ThinkStream platform is it's already pre-installed into all of the GSM, the 2G, 3G, and LTE networks. So already today provides a truly global network backbone that's deployed in over 190 countries. And the value that ThinkStream brings is the embedded application that they have wrapped around this USSD messaging protocol makes it much more easy to connect the embedded device using USSD to the cloud. And that's all built on top of the MQTT agent that ThinkStream has developed. So without further ado, what I want to do at this point is to hand over to Neil and Bruce, who can then start talking about taking those embedded devices and embedded software and connecting them into the cloud.
Thank you, Gordon. Hello everyone, it's Neil Hamilton here. Nice to speak to you again if you're joining from last week. So a very quick recap on what we covered last week to provide context for what we're going to talk about this week. Last time we were talking around how, the importance of having a low power, low cost IoT device, the importance of the ability for that to really happen to connect anywhere in the world. Is very important for many different vertical applications, and the ThingStream platform, as we covered, has phenomenal coverage to enable these types of devices to exist. We also highlighted the fact that, albeit the devices can work anywhere in the world, that it's very important really around how they work. And we were demonstrating in the previous webinar around how using MQTT along with MCU Espresso, you can actually start to build some interesting applications with these devices. And again, today Bruce will take that further in the actual demonstration. But ultimately, what you have here is programmable control with the devices. So once they're deployed, you can still manage the logic in the way in which they behave when they're out in the field. You don't want necessarily have to recore devices and increase costs of managing these types of solutions. So that's a pretty important area that we covered. Security was another point we touched on, and again, because as Gordon just said, we're effectively using we're getting devices to communicate using MQTT, a particular variant of that MQTT-SN over a channel called USSD that's baked into all GSM networks. There's no context of IP, there's no TCP/IP involved, so that makes these devices really secure. And when we're looking at certain verticals in the industrial sector, that's a very attractive and important proposition for anyone looking, or any enterprise looking to build a robust and secure end-to-end application. Then the low power aspect, again, we covered a lot of this, but again, we're not using cellular data. The devices we're using, or the components you can use are commoditized off-the-shelf devices that make these things very low price in terms of building the end bill of materials, and so that's important. And again, that comes with the fact we're using MQTT over the USSD channel, and also with battery power and things like this. There's a lot of we can get into this maybe later with the Q&A, but there's lots of ways in which you can optimize these devices to last for a very long time in the field, thanks to the lack of power needed in some of these application scenarios. And as I mentioned, a low bill of materials, and also the connectivity costs. Something we're going to show today is the application side, and the fact that the ThingStream proposition it's a bundled proposition. It's an intelligent connectivity proposition, and Bruce will clearly explain this when you get to see the server side aspect of what this connectivity offers. So last week, as I say, we covered the device, and we're talking about maybe how we can build the applications on board using the various tools available from NXP and ThingStream. But when you've got your device, and typically here is an example of a device that can last 10 years in the field, that's one part of your solution. The critical other half is really how the device will communicate and how you route the data or the information it's generating into a meaningful way into an IoT application, and maybe to get the application to talk back to the device should they need to, because again, this is all about intelligence and driving cost efficiencies or new revenues in your business through having new information available to you. And what we typically see with our partners and customers we work with around the world today is they'll build a device such as the one I just showed you, and that's communicating MQTT on a periodical basis and sending its information to a server somewhere. But in the prototyping stage, we typically find the end customer or partner has to source, first of all, an MQTT broker to build the prototype and then the production environment for this type of solution. And then typically need to either write an application from scratch in order how they're going to do that, or they might use popular products such as one you may be familiar, which is Node-RED, which again is a visual wiring tool to bring together APIs and endpoints and devices together in a relatively straightforward way. And this is quite a common tool that we do see regularly in our business. The challenges with these, building the software side or building software using different components, one, it's additional skills that an engineering firm might need to outsource or a company need to find. And again, it may work perfectly if you've got a single scenario where this particular device is monitoring the telemetry coming from a a crane or any single device anywhere in the world. But challenges occur when we start to want to manage fleets of devices and individually monitor them or communicate with them, and seeing them as a big cluster of devices. Then the software side of things get more interesting, and these products, such as some of the MQTT brokers you can download for free and host yourselves, along with the Node-RED type tools or the applications you build, then you need to be specialists in carrier grade software implementations, needing to have the skills to enable these things to be able to both scale along with your business, but more importantly, run reliably and have multi-threaded sessions that all run at speed, so your business isn't hindered in any way. And these are things that people usually discover after building that prototype, a bit later during their proof of concept phase. And we think, along with the ThingStream proposition, you needn't worry about these things. By using ThingStream, we can start to eradicate those problems that you may not have noticed coming down, your runway, so to speak. And it only gets bigger as we start looking at huge volumes of devices, such as thousands of cargo containers or thousands of different types of devices, even tracking vehicles across large geographies. Again, each individual device on board each individual vehicle in this scenario may have to, independently communicate with an application because its rules have changed. But as an enterprise, you want to be able to manage those types of applications centrally in a unified and easy manner. So I'm now going to pass over to Bruce, who last week, was talking about more around the building the applications on board the actual device to be able to connect globally using the ThingStream platform. We covered off some of the broker side of things, but I'm sure he'll touch on some of that today. But more importantly, we're focusing on the application side of ThingStream and about what you can actually do using the cloud tools to really bring an application to life and create your end-to-end value solution. Over to you, Bruce.
Thank you, Neil. We're just doing a bit of musical chairs here. Excellent. As Neil mentioned, we're going to be running through a bit of continuing really the demonstration that we did last week. You'll recall, those of you who are here, that what I'm going to be showing you here live is a development environment I have sat on the desk next to me, which consists of an NXP LPC Link 2 connected via to JTAG to one of our buttons. So these are hardware devices that we've built as a proof of concept to show how the ThingStream platform can work. This particular button, you'll see in the right of the photo there, is based on the NXP LPC824. So you have to think, when you're seeing all of this context, that this is a processor that has 8K of RAM and 32K of flash. So it is really a low-cost embedded microcontroller that can be used in replacement of things like other 8-bit microcontrollers typically. In addition to that, which is the hardware I'm going to be showing, I'm also going to show you that we're going to be writing some code using MCU Espresso version 10, and I'll also be showing you the ThingStream web UI, which is accessible to anyone. You can all go and sign up at thingstream.io and try that out. And also I'm going to be using MQTT Box, which is a Chrome plugin that just allows me to see MQTT traffic and data, which is useful just as part of this demonstration. So as Neil mentioned, if you look at the ThingStream platform architecture, in the first session we talked about the stuff on the far left-hand side, really the SDK that you see in the bottom left-hand corner and how that communicates with the MQTT SN gateway. In this section, we're going to be talking more about the MQTT broker that we host in ThingStream. So we have a scalable, reliable MQTT broker that is designed and has been demonstrated to process billions of messages a day. So that is a highly scalable MQTT 3.1.1 compliant system. And then on the right-hand side of this, the application platform, which allows you to create applications based on a flow kind of paradigm and then attach them to the MQTT broker. That application platform can be used for doing a whole variety of things. You can build whole applications in that, and I'm going to show you a very simple one today. But you can also use it as a very easy way to transform data before passing it on to other IoT applications or onto enterprise applications. So what I'll do now is come out of this temporarily and bring up the bits and pieces I need in front of me. So those of you who remember, this is the MCU Espresso workspace that we have here. This allows us to see all the code, and this is the ThingStream SDK that runs on the button device that I have here beside me. For those of you who remember, last week we got to the point of having an application where if I basically, when I fired up the application, it waited for me to press the button on the hardware, and when we did, it essentially sent our GPS location over our protocol MQTT-SN and was picked up by the server. So we're going to start from that same point. So if you all can think about that, we have this device here where pressing the button activates it into doing something. In this case, it is simply taking location information and sending it over the area, over the wire. Now, obviously, you can think of this could be anything. We could be picking sensor data up when we're doing this, driving this off a loop with sleep, with going into a deep power down, deep sleep states to build something that happens in a cyclical way. But I'm going to make some changes to this code just to show you to show you what we can do with this. So first thing I'm going to do is actually turn off GPS. So in our application, I'm just going to comment out that line to turn that off. Now, the reason I'm doing that is because it will demonstrate another area of the application platform a bit later on. In actual fact, where I'm doing this demonstration at the moment, we are indoors in an office, and we're not going to get GPS information anyway. But that doesn't stop us getting a location fix, as I will demonstrate to you. So the first thing I'm going to do now is just quickly clean that project down and rebuild it. And then I'm going to run this up. So I'm going to debug this. So this is copying the application onto our hardware. And I'm going to set that going. And at the same time, I'm going to come over here to MQTT box, and I'm going to subscribe to this MQTT topic. You'll see here what I'm listening to in an MQTT sense is basically a publish operation being done by any device in my ThingStream domain. I've got this button attached to my ThingStream domain. As you can see here from the debug, in the debug window down here, it's waiting for me to press the button, so I'm going to do that. Hopefully I'm not going to hit the disconnect the GA tag while I do it. This all looks good. So it is doing its thing. It's going to start to send the information. It's basically now connecting itself to the GSM network, establishing a connection, and there you go. You see it's produced some data and sent that over the wire. We'll see that appearing on that MQTT topic device publish in a moment. When it will debug out for us, logs the data. And then what we're going to do is I'll show you then the ThingStream platform and some of the operations you can do to transform that data when it has arrived in the server side. So there you go, there's the information there. Now, what you'll notice if you look in this payload here that we've got on the right-hand side is it tells us some information about the button state. Was the button pressed? Was it a long press? No. But you also see what I've done there is it's actually done a cell site survey. So I mentioned, and Neil mentioned earlier, that ThingStream is an overlay network that runs across all 2G, 3G, and LTE networks. What we've got here is a cell site survey of all the cell towers that can be seen by my button. It's not restricted to one carrier. You'll see there are different MCC, MNC combinations within this within the data payload here. And what I've done just then is send that JSON payload over the wire to our server platform to this topic, and I'm using MQTT box. I'm just simply able to see that and debug it. So having done that, what I'm now going to do is go into the ThingStream console. I'm going to log into my ThingStream account, and I'm going to show you a few things that we have in here. So this is the ThingStream console. If I pull that out the sidebar, you can see it's my account, and there's a number of things I can do here down the left-hand side. If I go into things, you can see all the things I've got in my account, and that particular button that we've got is this one up here, 1001. You can see it's active, and you can also see the last time that it was connected to the platform, UTC. So as you can see a moment ago when it sent that data. And I can do other stuff in here. I can disable it, for instance, deactivate it. I can get more information about my thing. So for example, when it's actually communicating, there's messages in flight, I can see all of those type of things. I can also see the last data that it's published, and also any subscriptions that it's got on the server side. So those are topics that it's listening to and subscribing to. So there's a bunch of information there. And I can even go into more detail and debug the USSD traffic that's actually going over the air. Now, obviously, this doesn't mean a lot to most people. It's there purely for debugging. Sometimes when people are working in the early days of getting hardware working, it's useful to be able to see this information to make sure everything's working correctly. So having done all that, the first thing I'm going to do is we're going to change our application now to send some slightly different information to a different place. So you saw previously that we are publishing that data. We were publishing that data, but not to any particular topic. So in this particular case, what we want to do is publish some information to a different topic. Inside the ThingStream platform, I have a number of topics that I've already created. And I think, as I told everyone last time, we actually use a variant of MQTT called MQTT-SN, which was originally developed for sensor networks, and it has some differences in some of the life cycle things you can do with it, which enable you, when building devices that are particularly power conscious, to be able to provide better interactions when they wish to go into low power states. And also, in order to optimize the amount of data transmitted, it allows you to create aliases for topic names. So instead of long topic names having to be passed over over the cellular network or over the wireless connectivity every time you send or receive a message, you can create aliases. And in this particular case here, I have this alias GOIN, which I've already created, and I've set it up with an alias 104. So in communication between the ThingStream platform and the button, rather than having to specify the text string GOIN, which doesn't seem long in this case, but you can imagine it could be a really long topic name, I can use the alias 104 instead. So if I go back to my code here, I'm going to change this, and I've got handy cut and paste in a buffer here that I can just stick in. So let's grab that from in here. I'm going to paste that in here. So what I'm doing now is I've created a new topic. It's a predefined topic type, and its topic ID is 104. So that matches the GOIN topic that we've created on the server side with that alias. And then I'm going to change this variable just to be GOIN. So as you can see there, so this is from our API, the publish operation, and I'm now publishing this to the topic GOIN. So that's the first thing I've done, is to modify that. So I'm now going to clean that again and build it out. So just to make sure that's all working the way we expect, if I close this down and change this topic to GOIN and subscribe. So now let's see what happens. We're going to debug this application again. Debug as local. Oh, sorry, I hadn't shut down the previous one that was running. My fault. Let's do that again. Okay, start that off. Again, it's going to wait for the button press. So if I bring up MQTT box here, and I press the button, here we go. So we're going to see the same data, but what I've demonstrated to you is just how quick and easy it is to change which topic we're publishing that data to. So it's a pretty simple state of creating a new topic variable and basically passing it into the publish method. So there's the data that's being picked up. It's now doing the publish operation. And we should see that appear in the GOIN topic in a couple of moments. Now, once we know the GOIN data is going into the platform and it's going to the right topic and everything's working, what we're going to do is use the application platform that we talked about to create some logic on the server side that is attached to this topic that's going to execute when messages arrive on this topic, on the GOIN topic. And I can do all of that stuff using the visual tools that we have within the ThingStream platform. So there you go, there's the data. We've changed the topic correctly in the source code, we've published the information, and it's now there. So let's get that out of the way and go back to the ThingStream web UI. So here it is. So what I'm going to do is we now have data going to that. And if you wanted to build an application that's purely MQTT based, you now have it. If you have, from your enterprise, if you want to connect via a regular MQTT client, you can connect into the ThingStream platform here and now you can send and receive data from sensors, devices out in the field. So if that's the way you want to integrate, you're good to go at this point. But we're going to do something a bit more sophisticated. So I'm going to go into a part of our platform called flows. And I have a flow here that has got nothing in it at the moment, but I've been using it for doing some testing. So I'm just going to go in there and edit the flow. Now, the first thing to note is these flows, they're applications in their own right, and you can combine many of them together to create much more complicated parts, but they all support things like version control here. So in this particular section, there are various different versions of this application flow that I can edit and change. And I can also put them in a test mode or in production mode. And there is a difference to the way they operate. In test mode, you're able to get live debugging information out of them, so you can see what they are, and you can very rapidly do the kind of test, deploy, execute, debug cycle. Once you're happy that it's working correctly, you can then deploy it into production, and your application then deploys on a very high performance infrastructure that again is designed to scale to processing billions of messages very efficiently. So I'm going to take this version, I'm going to edit that. You'll see it says up here what the version number is, and it tells me it's currently not deployed. So once it starts, okay, so you see what we've got here. I'm gonna, let me just get that out of the way. There we are. We just simply have a very simple structure of this currently, where we have a ThingStream subscribe node here, and then this is just a debug node. So anything that comes through this will appear in this debug tab, so I can see it. Now, a number of you will look at this and say, that looks awfully like Node-RED, and you'd be right to some extent. So this visualization that you're seeing here, the editor, is indeed based on Node-RED, so it provides the same paradigm, flow-based paradigm that Node-RED has. However, when you deploy this into test and production, it does not deploy onto the Node-RED runtime. It deploys onto our own completely built from scratch runtime that actually, functionally, the platform underneath is developed entirely in Java, where each one of these nodes is effectively a scalable and auto-scaling cluster of systems in their own right. So you can pump through very large quantities of data into this platform and process it in real time. So it doesn't run, from a runtime perspective, anything like Node-RED does. So here we have a very simple case. The data that comes in off the topic is just going to print out in the debug. And we're going to change this to make it a bit more useful for us. So the first thing I'm going to do is going to go to the palette down the left-hand side here. And I'm going to find some different things. So from that data that comes in, I know that it's JSON data. So what I'm going to do, first of all, is turn it from plain text into a JSON object. Once I've done that, I need to process that data in a certain way. So I can pick up a function node here. And I can double click on this, and I can stick some real server-side code in here. So I'm going to type in process data. Now again, here's one I prepared earlier, so I know what this is going to look like. I'm simply going to put that in here. And the reason I'm doing this is, if you recall, when we had this data that came through in the JSON payload here, I don't actually need all this stuff. So I'm basically, this bit of processing is simply stripping out all this stuff at the top and leaving me with just this block called GSM location, which is what I'm really interested in. So that's, if you look here, is exactly what that's doing. It's just basically stripping out the GSM location section, or keeping that and dumping everything else rather. So now we've done that, one of the things we've got down here that's really useful is this cell location node. Now, the cell location node basically uses that cell tower information, the MCC, MNC, and signal strength, to build a location based entirely on cell site survey. And again, it's just a node here that you can pick up off the shelf, and I've dragged it into the flow, so I'm deploying that. Then what we want to do is produce something else that uses the output from that. So the output from that will be a latitude and longitude, which is useful in its own right. But what I really want to do is to create an application that does something more useful with that. So I'm going to take that, drag the function node over here, and again, I'm going to give it a name. And what I'm going to do is copy in this chunk of code here. Now, this code isn't that long, but it actually implements a geofence. So this is the set of coordinates that represent that fence. And in fact, that's actually the map of the geofence in question. So you can see what it is we're looking at, the points that make up that particular geofence. And I'm actually in that geofence with my button. So when I press the button, we should be able to tell whether I'm telling you the truth and I am actually within that geofence or not. So that's what this is all going to do. So I'm happy that that's all good. So I saved that. Now, finally, it's quite interesting to find out whether when I press the button I'm in the geofence, but let's do something a bit more interesting than that. Let's go down here and find us in the output section. What we're going to do is send me an email that tells me whether I'm at home or not. So again, I'll connect this one down here. Oh, sorry, before we do that, let's do one other thing. I'm going to get ourselves a switch node that's going to test to see whether the output of this is in the right place or not. So I'm going to take that, connect that to this, open up the switch, and I want to check the property message.payload.inPoly, and I want to do something if that value is true. So this switch node is basically saying if this value message.payload.inPoly is true, then output the message downstream. So if I'm not in the poly, I won't get an email. If I am in the poly, I will get an email. All good. So let's move that down there, grab this, drag that there, configure up this. So this is going to say at home, plain text to send it to me, bruce.jackson@thingstream.io. So a very simple bit of message there. So I could do all kinds of things with this particular component, but in this case, all I'm doing is going to send an email if I am at home. So there we go. That is it. Now, I'm now going to save that. And the next thing I'm going to do is deploy that. And I'm going to deploy it to test. So let's do that. When I come to deploy it, it now asks me what I want to do. Where do I want to deploy that? Do I want to deploy that to listen to all types of things? Or do I want to deploy it to an existing topic? Well, we want to deploy this and attach this flow to be executed every time a message arrives on GeoIn. So an existing topic is what we want. So I click that and it gives me a list of all the topics I've already created. GeoIn is the one I want. So there we are. Just going to confirm that. Deploy this, to hit the deploy button to deploy version 3 of this flow and subscribe it to GeoIn. So we'll do that. So that's now. You can see this now says at the top of the screen, subscribe to GeoIn. So now we've got a relatively complicated application. We take data in from an MQTT topic, we convert the data into JSON, we then initially process it by basically stripping out all the unwanted parts of that JSON data payload, just leaving us with the cell tower survey. We process that cell tower survey with our component that gives us a geofix based on cell towers, so that's going to give us latitude and longitude. We're then passing that into a geofence that says, am I within the fence? And then if I am within the fence, carried out by the switch, send me an email. So that's what we have now. So that's running, that's live. What we're now going to do is go back over to the button. It's still waiting for me to press it, so I'm now going to just gently press that. And let's see what happens. So we're running through the data again. If I go back to MQTT box, you'll see this is still subscribed to GeoIn, so we should see the second message of this come through on this topic as well. So it will still go to, in the way that MQTT works, every subscriber to a given topic will receive the message. So in this case, we will get a message going to GeoIn, and we'll also get a message to GeoIn being triggered, that flow being triggered. And let's hope I didn't put any typos in any of the things that I pasted in there. So the sequence is running through. And there you go. At the top of the screen, there is the email. So that's what I was hoping would happen. Everything has worked exactly as expected. So what I've demonstrated there is really building a relatively complicated application, but without writing a vast amount of code. Admittedly, there is some for the geofencing, but that's the nature of geofencing. It's got to do a bit of maths to get there. But I haven't had to do an awful lot to do something and to build an application that's functional. Now, the interesting thing is, while that's great here that I've prototyped it on my desk and we've done something that's interesting, by now deploying that onto the production infrastructure, by going back in there and changing it from deployed on test, in here, if I now go and deploy that live, that will now deploy onto the high performance infrastructure, and I could now have literally millions of these devices doing exactly that same thing, processing that data, and in this case generating millions of spam email messages, but processing all that stuff live on the platform. Now, the part of this that's important is that, as Neil mentioned, we at ThingStream believe that there are enough obstacles and complications to building IoT solutions without creating any more of them. So the platform we have combines not only the connectivity that you've seen that runs on all these networks worldwide in every country on the globe, well, 190 of them, but also this whole infrastructure you've seen server side, the MQTT broker, and then this application platform are all provided as part of the offering that we make. So we're not just providing a SIM card and some connectivity and saying, well, the rest is your problem, you sort it out. It's an end-to-end solution that helps you get something to market more quickly. Now, I could tell you a load more about the other things inside here, the various things that you can see within the ThingStream platform. Some of you saw last week that we have obviously the downloads of the SDKs and the software and the documentation. We looked at some of that stuff last week. And there are other things in here that allow you to manage your account, manage the cost in your account, set up things like bill on behalf of. So if you're acting as a system integrator and you're working with multiple clients, you can do that kind of thing. There's lots of stuff in here that are useful for managing your environment and also for doing things like turning devices off, creating real MQTT clients. But hopefully that has given you a bit of a flavor for the ThingStream platform and the kind of things that you can do with it. So with that, I'm going to pass back to Gordon to wrap up.
Gordon, you're muted. Just a heads up.
Thanks, Ethan.
There you go.
So thanks, Bruce and Neil. And at that point, we just want to reiterate, why we think it's important that this brings you a truly global sensor network that can be deployed, and with the platform that ThingStream brings and the total solution from connecting the edge node to the cloud and being able to manage and provision the sensor network, we think it's a really valuable proposition. So at that point, Ethan, I think we just want to emphasize our thanks to everyone for attending the session. We have links here if people want more information on the microcontrollers or the ThingStream solution that has been demonstrated today. The web links are there, and we are open for questions at this time.
Great, thanks Gordon, and thanks Bruce and Neil. We have one question right now, and I believe it's for Bruce and Neil, but is the software going to be ported to the latest SDK 2.4 and MCU Espresso 10.2?
The SDK that we offer does work in MCU Espresso 10.2, so yes is the answer. I'm just using an old copy because I haven't upgraded it on my desktop yet, but it works on the latest versions, absolutely.
Cool. Thanks, Bruce. Well, that is the only question we have for this time. If anyone has any questions, please send them in. If not, I think we can wrap up this webinar. Like I said, we will have this recording and the presentation material uploaded very soon. And again, for those who maybe missed part one, we will send those links out as well so you can catch up. But again, thank you all for joining. Bruce, Neil, and Gordon, thank you for presenting. And someone said thanks for an interesting presentation. Awesome.
Thank you.
Yeah. Okay. Well, thanks everyone for joining, and do keep an eye out for those follow-up emails that we'll be sending out.
Thank you.
Awesome. Thanks everyone.
That's all. Bye.